This is question 55 in chapter 2. We're given a sprinter that can maintain his maximum acceleration for 2 seconds and his maximum speed for 10 meters per second. So I've written up here the sprinter, after 2 seconds he reaches his max speed. In that case the acceleration is maintained to that point, and then his max speed is 10 meters per second. Assume that after he reaches his max speed, his acceleration becomes 0, and then he runs at constant speed. Assume that his acceleration is constant during the first 2 seconds of the race, that he starts from rest, and that he runs in a straight line. How far has the sprinter run when he reaches his maximum speed? So to find that, we have to use this formula for range. So r vector equals the starting position plus the initial velocity times time plus 1/2 acceleration times time squared. So his initial starting position is 0, his starting velocity is 0, and 0 times time, that changes to a 0, plus 1/2, and his acceleration is change in velocity over time, so 10 meters per second over 2 seconds times the 2 seconds squared. And that'll give you 10 meters. Now the second part asks, part B asks, what is the magnitude and average velocity for a race of these lengths? 50 meters, 100 meters, and 200 meters. So I'm going to erase this. And for the first 2 seconds we need to find out how far he's going. So if we look at it this way, in the first 2 seconds he goes 2 meters, and then we know that his speed is constant after that. So you can just add in another 10 meters per 1 second plus 10 meters per 1 second plus 10 meters per 1 second plus 10 meters per 1 second. That'll all give you 50 meters per 2 seconds, or 6 seconds, which gives you an average velocity of 8.33 meters per second. And that's going off of the equation velocity average equals delta r, or delta x, over delta t. So we're going to do that same thing for 100 meters and 200 meters. So for the 100 meters, you can say that he will travel 90 meters in 9 seconds because his speed is constant after he reaches his maximum, and we already know that in the first 2 seconds he reaches his maximum speed. So you can add on the 10 meters per 2 seconds because that's the first 2 seconds, and your total distance with these added together is the 100 meters. So that will be 100 meters in 11 seconds, which will equal 9.09 meters per second. And then for the last one, for 200 meters, you'll do the same thing. So 190 meters in 19 seconds plus the initial 10 meters in 2 seconds will equal 200 meters in 21 seconds, which will equal 9.52 meters per second.